My name is Changjun. I'm a fourth year mechanical engineering student at Georgia Tech, taking a course on design and manufacturing, and I'm here to talk about my design idea, the elastic and gentle wrap. The purpose of this project is to improve a product of my choice that is frequently used by me. And I chose the tool, the keycap puller, that I use when modifying and repairing my mechanical keyboard for the topic of this project. The way I thought of improving the keycap puller is by focusing on the contact materials between the tool and the keycap itself. As you can see right here, and this is a durable and flexible design that is mostly applicable to the wired keycap pullers while preserving the user's original experience or methods of using the tool. An example of a wired keycap puller is shown right here. This design choice is mainly focused on improving the product via the design for human factors and ergonomics. So how does a wired keycap puller work? It works by bending the wire at a slight angle to position the wire under the keycap and twisting the handle to have the opposing corners of the keycap go inside the wire loops. And finally, to remove or separate the keycap from the key switch, all you have to do is pull on the tool. With the improvement implemented onto the product, the design targets the user's emotional and cognitive functions. The design is simple and intuitive as it easily attaches to the tool. The user doesn't have to worry about a possibility of damaging the keycap or keyboard whenever he or she decides to do some modifications, as the design creates a barrier and prevents the metal wires from interacting with the plastic keycaps, preventing any scratches on both the keycap and the base of the keyboard. It is also a design for ergonomics, as it optimizes the human performance when using the tool. Silicone rubber has a stronger grip on the keycaps, as it is more resistant to motion, and a stronger grip means an ease of removing the keycap and a decrease in the number of attempts. This leads to a reduction in the amount of extreme movements on your wrists and fingers, preventing the possibility of injuries. So before I present the improvements, first a little introduction about the components of a keycap puller tool. This is a pretty simple tool as it is only two components, a base for the user's fingers and the metal wire clips to grab onto the keycaps and the key switches during repairs and modifications. Spacers are used in between the two metal wire clips in order to space out the distances and allow both metal wire clips to elongate properly. Again, the areas that I'll be improving on are the metal wire clips. So here's the proposed design solution. It involves two of these silicone attachments, one for each wire on the tool. The hooks on the silicone attachment wraps around the space, connecting the two wires together. This is used to prevent the silicone from sliding off the tool when the user is using it to modify their keyboard. The rest of the silicone attachment has grooves for the wire to fit into and prevent any sliding from happening between the silicone and the metal wire. And with that, the design is implemented onto the tool and the tool can then be used for its designated purpose. The wrap again clips onto the spacers between the two wire clips and the rest of the wire clips into the grooves on the wrap. The hooks on the wrap are also made of the same material as the wrap itself, so during the tool's usage period, the tool and the hook are able to elongate as the wire clips are gripping onto the keycaps and key switches. When it is time to clean the tool, the silicone comes off easily by first removing the hooks from the spacers and then pulling on the hooks to remove the metal wires from the silicone grooves. As for the materials to be used, the wrap only uses one, and that is silicone rubber. Silicone rubber is used because of its resistance to weathering, chemicals, and UV radiation. It is also designed to be durable and flexible and also hygienic. It is hygienic due to its non-porous nature, which makes it resistant to bacterial buildup, and because of that, it is also non-toxic, water repellent, and recyclable. For the manufacturing process, vulcanization is used to produce the raw materials for silicone rubber, and this is done by adding curing agents to raw silicone compound and heating it to create a cross-linked network of polymer chains. Curing agents are used to improve the specific properties of silicone rubber, such as durability, flexibility, and color. The standard process may involve mixing, molding, curing, and finishing. Mixing raw materials are mixed together to create the base material for the product. For molding, the mixed material is then poured into molds to create the desired shape of the product, and thus can be done in a variety of methods such as injection molding and compression molding. Injection molding is just injecting liquid silicone rubber into a mold cavity under high pressures. Compression molding is basically just placing a pre-measured amount of uncured silicone rubber into an open cavity and then closing it with a hydraulic press. The heat and pressure applied causes the material to cure and take shape of the mold. During curing, it involves the material being cured or hardened by exposing it to heat or chemicals. And finishing product is then removed from the mold and excess material is trimmed off or polished or coated. A second vulcanization process may be needed to further cross-link the polymer chains to improve its mechanical properties like tensile strength, elasticity, and durability. It may also improve the performance and reliability of silicone rubber products. Testing after production is important as it ensures quality. These tests include tensile testing, which is measuring the force required to stretch a sample of silicone until it breaks. It helps determine the strength and elasticity of the material and provides information on the ultimate tensile strength, elongation at peak, and modulus of elasticity. A durometer hardness testing may also be used to measure the hardness or softness of a sample of silicone by measuring its resistance to indentations by a probe with specific shape and size. It helps to determine if the material is too hard or too soft for its intended use. A Fourier transform infrared spectroscopy test can also be used to detect any impurities or contaminants present in the silicone product. And finally, here are the advantages and disadvantages of the design solution. The advantage is that it attaches to the keycap pullers, which means they can be taken off easily. It avoids scratching the keycaps when using the puller tool, as the wire keycap pullers only apply force at the bottom edges of the keycap, and the twisting motion may scratch the base of the keyboard along with the bottom edges of the keycaps. They can remove multiple keys safely. Abrasive materials or chemicals that are commonly used to clean the keycap pullers during regular maintenance can also damage the tool, and the silicone cover acts as a protection layer against these factors and preserves the tool. Now for the disadvantages. The design idea is mostly for wired keycap pullers, thus it is more expensive and costly, as wired keycap pullers are slightly more expensive than plastic alternatives, shown here. The silicone elastomers are also a premium product with a premium price tag when compared to other rubber materials, but this is often offset by improvements in uptime and quality control. Bringing it back to the plastic keycap pullers, plastic keycap pullers are cheaper and easier to use. It is a simple push and pull procedure versus bending the wire at a slight angle to position the wire under the keycap and then twisting the handle and pulling the keycaps out. However, the plastic tool is not durable and is sometimes stiffer than a wire tool, which may cause damage to the material, paint, or coating of some keycaps more than wire ones. It is also less efficient as it only removes one key at a time rather than multiple, which can easily cause fatigue. Here are the references I've used when researching and brainstorming this particular design idea. And before I end this video, I would like to stress that I completed this project based on the knowledge learned from the design and manufacturing course, and this was just purely for educational purposes. And I was not made aware of any potential current or past patents that covered this idea. Thank you for listening.